I have a Suletta problem. This here is Suletta Mercury from the anime Mobile Suit Gundam, The Witch from Mercury. Or rather, this is the figurized standard kit by Bandai of Suletta Mercury. It's a kit that I built a little while ago. Now, it is a nice kit and everything, so it is very detailed, well articulated and whatnot, and as is common with figurized standard or figurized kits, you can actually swap out the faces for different expressions, for different faces to get like different facial expressions depending on your mood, I guess. So the problem is that we have only 3 swappable faces with a figurized standard kit. And you get 2 blanks essentially with preset mouth expressions, and you can like set different eyes from a sheet of water slide decals provided. The problem here should be clear that we have not enough faces for the number of eyes. I'm assuming like the concept is that you can like remove or scratch off the old decals and replace them with new ones. That's why we have so many spare eyes. But it would be nice if we had extra faces that we can just like apply all of these on with all the different combinations and permutations and just swap them as we please. Luckily, I have a 3D printer, which is nice and all, but that still means I need 3D files of these faces to be able to print them out. So to be able to get those 3D files, there's a few methods. Some of them are commercial, some of them are free. I'll skip the commercial methods, which usually involve you to get a 3D scanner of some sort with the name of an animal, like otter, moose, or raptor, whatever it is they are up to these days, and go straight to like a different method, like something called photogrammetry. Now, photogrammetry is a technique where you just take pictures of the subject that you want to scan from multiple angles and like, well, as many pictures as you can, and then the algorithm will kind of like match features and try to reconstruct a cloud of points to like create a mesh of the said object. So there's a program called Meshroom, which I've been playing around with.
Right, Meshroom. So as mentioned, photogrammetry works by taking a large number of pictures, or a fair amount of pictures, and try to reconstruct a 3D object from those images, basically using like, try to match the same features like between images and determine like what, like similar as how eyes work. Well, you have 2 eyes, and you can use like the difference, like this difference in angles to kind of construct like a depth, do some depth perception thingy. So Meshroom kind of works, like photogrammetry works the same way. So we have a pipeline here where we kind of extract, try to match like features in the object, and basically match the features, match the images, and kind of extract like a cloud of points out of this. So I'm not going into all details, but basically you end up with something like this, which is basically, it's upside down, but yeah. To explain what we're seeing here, so all these images are actually from a video. Let me just hide this. So, well, 3 videos. So I have this face here, which actually stuck on a piece of Lego, and this is on a turntable. And it's actually turning on the turntable at different angles. And then I put the camera at a fixed position, different elevations, different positions to basically take a video of the object as it's turning, and then extracted images out of it and fed that into Meshroom here. So this is what we're seeing. These orbits are basically where the camera was. Well, actually the angle, so it looks like it's in orbit around the object, even though it was the object turning. So it's kind of a flat earth moment, I guess. But anyway, so we do get like a point cloud here, which is technically called a sparse cloud, I guess. Not a dense cloud, but we can use that to reconstruct a mesh. I do not have a NVIDIA GPU, which is what they kind of recommend using This is actually called Meshroom CL. And yeah, I'm not going to go into all detail, but basically I can still use this to kind of reconstruct a mesh using different algorithms. So you'll see the results aren't great, as seen here. It's a very messy, noisy mesh. If I look in wireframe, you can see it's like a very, very knotted, messy looking thing. I cannot use this. I don't think we can use this for printing, even because I also need to be able to remove this Lego brick. If I load this in Blender with all these distorted, like knotted looking things, and there's holes in the mesh, like, let me just try to get this in position here. Yeah, there's a hole in the mesh in a few places. There's probably like bits of pieces they didn't manage to capture properly here. There's like missing faces in a few areas. So yeah, not the greatest results, even using different algorithms to oh, this one's a bit, yes, this one's smoother, but still, yeah, still, okay, this one's kind of, if I view it like solid or textured, whichever, this one is using a different Poisson algorithm to like do the meshing. We still have a general shape of it, same as before, but we have lost a lot of detail. The vertices are a bit cleaner, but still, it is not great. It is very approximate. I probably should increase it, but yeah, like the more you like try to increase the quality, like it takes way longer, which is not great. But yeah, this is not great. Even with filtering, it actually makes it worse, I think. What are you doing? Okay, let's ignore this. Let's ignore that. Texturing. There we go. But yeah, the end result with all the textures and everything, it is fine for like an approximate capture of the object. But if what we want here is like precise shape, at least, especially on the hairline, on the back piece here, because this needs to fit. This needs to fit onto a peg, and the tolerances are important. So yeah, we cannot use this as is. Right.
Turns out that photogrammetry alone isn't going to be enough to get a reasonable 3D object that we can print. It has too many holes, too messy of a result. So what to do next? Well, one of my initial ideas was actually to like try to use Blender or some 3D program to manually build this. Basically measure out the shape, or maybe take reference images at known angles or what have you, and try to recreate this curved surface, this organic shape. Trying to sculpt it like freehand would probably be too difficult, but if I were to use, like, say, rotate it at set angles and like recreate the outline at that angle, maybe I can like reconstruct this shape in Blender. It might become a bit more obvious in a minute here. So what I kind of did was I built this rig, which is just a 3D printed shape here, 3D printed like stand to kind of mount the faces on. It kind of has the same, it's a peg that fits this hole essentially, and it allows me to use this flat edge here as a reference place for the z-axis, or z-axis really. And basically we have like right angles inside the hole, so we can use those for our axes. So this would be the x-axis, this way would be the y-axis. So yeah, if I mount it on here, which is then pinned into place in the center of this protractor here, and we can kind of then rotate it. And as seen in the picture here, you can see the camera setup. but the camera is like in line with the on the same plane as the protractor and taking pictures. So yeah, so now I just rotate it like at set angles. So taking it not 180, well, plus 5, plus another 5. So basically just like rotating it like that, and then until I take all the pictures, and then you end up with a result like this.
So given this set of images at different angles, we can use that to kind of recreate the curved surface. So it's kind of a janky technique, kind of approximate, but it sort of works for this. So what I did was go into Blender here and let's go to the front view, go to orthographic projection, and we just center this here. You're not centered? You're centered. Okay, Shift C. No? Okay, fine. Then add an image as a reference. Taking one of our angled image here, the first one. This is like 0, so yeah. So what we have here is basically an image. So usually now what we do is like add a curve to kind of like match this exactly, but I'm just going to go do it a bit approximate just for this example here. So I add a plane, go to edit mode, delete the vertices, just start over here. So this is just for an example. So what I'm going to do is kind of, well, it's a bit inside, but it's supposed to be a bit more outside. Probably should have deleted the black part, made it more transparent. So, Ian, come on. Just kind of, why are you so slow? You're supposed to be a bit faster. There. It's weird. It's supposed to like control click to basically. Need to click a long time, apparently. But anyway, yeah. So basically, I kind of matched the curve, the outline of the face here. Could probably do the rest of this, but probably not. Not necessary. Just like I just want the front face, the curve. So now I have this. Go to number 7. So you go to the top view, select the plane again, select all the points, rotate it by 15 degrees. Actually, not like that. We need to rotate it the pivot being the 3D cursor, which is right now centered at origin. So we rotate it 15 degrees. So now it's rotated. Now we go to our image again, and we change. Change. Where are you? Where's the damn image? Oh, there we go. Sorry. Yeah. There we go. Image properties. So we just change it to the image at 15 degrees. So now we have this. That's the old plane rated at 15 degrees, and the new plane is going to be drawn here. So actually, this is because at 15 degrees you no longer have a nose. This is like trick of perspective. Well, you're gonna have to use your human intelligence to figure that out. This is where probably AI would fail, or maybe it does work. So again, rotate it by another 15 degrees. So now we go back to the front. We change the texture again. to 30 degrees now. And we keep going, essentially. Yeah, we don't include the nose in this bit. This is basically what I did. And rotate by another 15. Go back to front. Change the image again. Let's put it to, let's get 45. Let's go directly to 60. Just for doing at 30-degree angles now. And select this. Basically, we get more of the curve here. Be sure to stay in the same plane. Now, let's hide this. Just going to give you an example of what I'm doing here. So you can see. Oh wait, I think I already did. Yeah, I already did like 15 degrees, but I should have already did 30. So basically, yeah, I'm basically like doing slices, like a slice of cake, but of the face, and doing the outline, gradually getting the various points on the curve. So at the end of all this, what do we get? This. So this is the face curve as like reconstructed at different slices at different angles. Yeah, I end up like 1, 2, 3, 4, 5, 6. Basically everything at like 30-degree angles or 15-degree angles, essentially. Yeah, you can basically get like the curve, the front of the face, which is enough. And if you combine this is the curves, and you combine this, actually, let me show you what it looks like, the various points, and if you drew a line through all these points, you would basically get like the shape of the face, roughly. And I kind of use also the output from the photogrammetry, just cleaned up a little bit, or tried to anyway. This is going to be still used as a reference to kind of like get the general shape. Plus, I use a bunch of images to kind of like reference images from like of pictures taken from various angles, including images from the manual here, which has like luckily like a front projection of the face with like various features that we can kind of use to match things. So basically what I'm doing is kind of like photogrammetry, but like very guided type. So let's hide this for now, hide the curves. We can take a look at the images, which is basically I took pictures from the angled stuff that I was working with, like from left and right, which they match basically almost exactly the shape, because the angle was measured with a protractor, so it's fairly accurate. And actually, the nail at the bottom here was kind of used as a reference point to like line everything up, so it's like fairly accurate out of the gate. And we also took pictures of the hair just to be able to like get extra details, like match the hairline with the face that we're trying to recreate here. So yeah, lots of reference images were used to reconstruct this. So in the end, what we get is, let me just and boom. Nope. Hold up. Let me just hide the various bits and pieces I want to show yet. So, alright. In the end, we get this. this is the face, at least half of it, reconstructed. So do not move this. It is locked in place, so it doesn't move. Never mind. Yeah, so basically, as you can see, this is a very low polygon reconstruction of the face using those curved the curves I showed you earlier, reconstructed from these angled reference images. There's some there were some adjustments. Essentially, it's not only those things. There's also some observing the actual object and basically like cleaning it up a little bit. Shape key is locked. Never mind that. This seems a bit out of place. But anyway, so we basically got this, and then if we add a modifier to kind of mirror it, we get the full shape. Actually, you can kind of see in here I kind of added a mouth. This is going to be relevant later. So yeah, at this point basically we're starting to get somewhere. So we have the full shape of it, and then if I add a modifier to smooth it out, subdivision here, Catmull Clark, and that actually makes it way smoother and looks more like itself. So you'll notice that I don't have the hairline yet, and basically this is just one big block, just a face sticking out. So the next step is to actually cut those out, essentially. So yeah, using Boolean modifier and a bunch of cuts, which you can kind of see here, it's different. It's not just, instead of trying to smoosh all the details into a single mesh, just have small bits, break out the complex detail into separate meshes, and just use those to carve out the face block here. So in the end, yeah, we have all the bits and bobs here. There's something to note here, kind of included a print bed cut. This is going to be the flat surface that is going to rest, that's where where it's going to be in contact with the printer surface. And yeah, this is going to be flat, and that's going to be printed in this direction upwards. Right, so then yeah, we have that, all the various cuts, the hairline from the front, hairline from the side, everything really, and it works out. So yeah, now we had the ears, we had the peg, which is a more simpler geometric shape than the face, so it was easier to reconstruct. We just measured out the peg and kind of made a hole that kind of matched it. Yeah, so we have basically this is the base face. Didn't quite get the smile right, but it's close enough. Yeah, so this is textured. You can see the lips are green, but that's only for me to be able to spot where the lips are. That's going to be relevant in a second. So yeah, I have this base face now, so this is great. I can print it like this, or yeah, I mean, I can also use shape keys to kind of create different shapes out of it, just because as I mentioned, I added lips and a mouth. So basically now I can create various expressions for the mouth. The thing, okay, that's inside here, that's our tongue. It looks like a watermelon, which is not intentional. That's how it does. I textured, I used the green material for the lips here, just so I can know where the lips are, because to avoid the mouth to being overly distorted by accident. Some of these require a bit of work, probably just some tweaking here and there, but some of them are fairly okay. Yeah, fairly decent. Yeah, more or less. You can do like a Neko face, although it looks like more like a monkey than a cat at this point. Probably need to like tweak that up a bit. Yeah, so the base face and the shape keys are great to be able to reproduce the the various expressions, and we can print this out and apply the decals. And what happens when we run out of decals? I forgot teeth. So yeah, we can what can now also add the eyes to the mix here. So this is just same deal. Basically use reference images to draw the eyebrows and basically make shallow meshes, I guess, of the eyelashes and some other markings, including the white of the eyes and the pupils, I guess. And those are actually using a technique called, well, a modifier of the lattice to basically like project those onto the surface. So it's actually built outside of it, and then it's like projected onto the face surface. So it will, when you like change the shape of it, you can actually, if I unpin this, I can actually like interpolate uh, the shape keys. So can move the eyebrows and like do between normal and angry. Except if you go over, it kind of gets into weird territory. So yeah, you can kind of like have. I guess this is good enough. It's like slightly angry, very angry. I guess maximum anger. Way too much. Now you look like you have a cockroach on your face. That's just weird. But yeah, you can just go back to the base shape here. You can also do like a closed eye, but it works better when the eyeballs are gone. Right, so yeah, you can just print it like that. And we shall do just that, I guess. Do the basis. So yeah, if I were to export this selection and load it into the printer.
So now to
software
slicing.
slicer.
So
Yes.
I'm using Ultimaker from Cura to do the slicing and not the Creality Slicer program, just because the Ultimaker comes with like the profile for 0.2 millimeter nozzle support on the printer that I have. For whatever reason, Creality's Slicer does not do that. I mean, you can create a new profile for it, but the settings were kind of getting out of hand and was complaining about a lot of things. And this one already has the profile. Obviously, I already changed the nozzle on my printer, so it's all right to go over there. But yeah, so now I can open this in here, and we can get the slicing. Right, so now when we load it, it's like vertical, so we can't really slice it like that. So we need to select it, rotate it, and rotate it, and then select the face to build plate. So remember that cut that we did that was like flat. So basically it's like this face here like falls down, and this is basically going to be lined up. This is going to be contact surface onto our build plate. So now that's where it's going to be printed. So some people are thinking that maybe a resin printer would be better for these kinds of things, but the problem is like I do not have a resin printer, and from what I've read, it's kind of a pain to deal with. There's more maintenance and more costs associated, so probably not going to get one. So I'm going to stick with my cheap filament printer for now and try to make do with what I have. But yeah, so now for now I have this. It's like very nicely. It came out nicely from the export here. So let me just slice it. Take a look how it looks. Preview. There we go. So, oh, this is on 0.04. But yeah, on 0.04, it's like the small, like, this is the smallest layer height it can print. So it is very,
very fine detail. So normally, like for somewhat draft models, I'm using 0108. It is still very fine detail, but it is it prints like in about 30 minutes, so per face. So it is not too awful. So I can get like a few prototypes out in a day and make some modifications. So yeah, we get this, which is quite nice. It does require a brim to be printed because this contact surface is like very small, so you do need a brim. I never understood why you have like some of them like have a giant skirt all the way around, far away from the thing. That does nothing really. But yeah, so we have it. So we just export that and we see how it looks. And if you want to create like different facial expressions, just for example, we just remove the eyeballs. Just go to for the eyebrows. Just close it. I guess. What else do I have? Let me see. What do I have? If I unpin this, oh, it's already at the. Oops. Seems to be in a reasonable shape. Yeah, we have teeth now. That's the thing we didn't have with the like the default meshes. She was basically toothless, but now I can add teeth and basically do all sorts of weird things with it. Yeah, a bit weird, but what have you. So we have the teeth poking out. All right, so now this is a shape, the face that we can print. And if I to export this, and then we just load it in here. There we go. And do the same thing. Select it, rotate it, align to the build plate, slice, do preview, check it, I guess, still 0.08, just take a look inside. Yeah, we have the tongue, we have the teeth. It's not great. I mean, like it's like floating, but yeah, might be fine. Like at 0.02 millimeters, like the filament, like the extrusions, cools down very quickly, and you can print stuff like this fairly. Like this works because this will cool down and solidify fast enough that you don't have to worry about it sagging. It would be a problem on 0.04 millimeters. Yeah, so then we just slice it, save it, and we're good to go. Yeah, so we take our smiling face here that we just finished printing and we're just cleaning up a little bit. So yeah, I'm using a file here, but basically you could use, you could use a knife, I guess. So yeah, we just remove the, I got a bit of crap on it, but get up there, you. But yeah, so clean it up. It's more or less clean it up a bit and
just might use a file after all. Just deeper that brim, or remove that brim that was making it stick to the build plate, and kind of round off the ears a little bit. So yeah, that's the basic idea. You now have a face that you can use. Just polishing this a little bit. The inside here probably needs to be, there might be some like stringing, so you need to like remove this. So I kind of calculated it so that the hole here is slightly larger. The tolerances are a bit more permissive than the like original peg and hole here. So yeah, you can just remove her face and kind of put that on there, hopefully. And there we go. There's some fits issue here and there, but basically, yeah. So then, magic. So now we managed to solve the problem of not having enough faces. And yeah, we can print all the faces we want. But yeah, so now that becomes a different challenge, because now, maybe, perhaps, not saying anything, but it's entirely possible that I have a different set of problems now, that maybe, perhaps, I have too many faces. And yeah, so alright, to put it simply, I think I may have a Suletta problem.